Hi, Garrett. Sorry for it's taken so long. It has taken forever to get connected.
It's fine, thank you.
So if something happens and it gets kicked out, if I'm not able to log it back in, I'll have to set up a hotspot. And so if that'll take me just a little bit of time. So just if something happens and we get kicked out, and I just try to log back in and just hang out in the waiting room until I get it reconnected. But hopefully now that we've made the connection, we'll be good. So sorry about the delay in getting it going.
All right, thank you.
If you guys have any questions at any point, be sure to let me know. I'm going to go ahead and share my screen, and we will get started on checking homework. So we're going to be starting on page 146, checking our homework. Yeah. All righty. So here we go. Page 146. We had numbers 146 and 147. We had 8 through 26 even. So starting with number 8. Okay, so in number 8, it says to find the measure of angle 1 and the measure of angle 2 and to explain your reasoning. So what is the measure of angle 1? 135 degrees. And why did you say it was 135 degrees? Corresponding angles. Awesome. What is the measure of angle 2? 135. Why? Huh? Oh, they are congruent. Why? What position are they in? Vertical angles. Good. Because 1 and 2 are vertical angles. We know that 1 is 135, therefore 2 is going to be 135. All right, look at number 10. We're needing to figure out angles 1 and 2. Okay, so what is angle 1 going to be?
118.
Okay, so 118, why?
Alternate interior like postulate.
Okay, so we've got the alternate interior postulate. And then, so what is the measure of angle 2?
62.
62 degrees, because why?
Because 1 and 2 vertical angles.
No.
Linear pair.
1 and 2 are a linear pair. We know that a linear pair equals 180 degrees. So if angle 1 is 118 degrees, then 180 minus 118 is going to be 62. Good job. Any questions on either of those? Okay, let's move on to number 12. The directions say to find the values of X and Y and explain your reasoning. Okay, so number 12, we see that we have an angle of 109 degrees, and then we have to figure out X and Y. So what did you find that X is in number 12? 71, and how did you find that? Consecutive interior angles tells me that when I have 2 interior angles, if I add them together, they equal 180 degrees.
What does X equal?
Huh?
What does X equal?
71. So because 109 plus 71 equals 180, okay, so we know that those 2 angles added together will equal 180. So what is Y going to equal?
109.
109, and Y? Vertical angles. Good. So Y is vertical to that 109 degrees. I know that if I add 71 to 109, that equals 180. So I was able to find X and Y. Let's look at number 14. 14, I have a degree that tells me 65 degrees, and I need to find X and Y. What is X equal to? 65 degrees. Why? Corresponding angles. Okay, corresponding angles. So this one is in this position. This one is in this position. They're corresponding. They're on the same side as the transversal, but one is interior and one was exterior, okay? So those are corresponding. They're in the corresponding locations. So if X is 65 degrees, what is Y? 115, good. All right, number 16. 16, I've got 130 degrees marked. I need to find X and Y. What is X going to be? 130, Y. Corresponding angles, so what is Y? 130, Y. Vertical angles, okay? Because X and Y are vertical, we already found that X is 130, therefore Y is 130. 146. Okay. Moving on to page 147, starting with number 18. Find the value of Y. All right, so first of all, when I'm looking at these, I've got to look at how these two angles are related. Okay, so what is our relationship here with these two angles?
Alternate interior.
Alternate interior, so we know that they are corresponding. So what is my equation to solve for Y?
2y equals 70.
2y equals 70, so I divide by 2, so y is equal to 35 degrees. Remember, stop me if you have questions. Number 20, what is my relationship here?
Consecutive interior angles.
Consecutive interior, so I know that if I add them together, they equal 180. So I have 6y plus 120 equals 180. Okay, so I'm going to subtract 120 and I'm left with 60 degrees. And so 6y equals 60, divide both sides by 6. So y is equal to 10 degrees. Questions about those?
I got y equals 20.
Okay. Okay, so what is 180 minus 120?
What I did was I did 120 equals 6y and then divided both sides by 6.
Okay, so they are not equal to each other. These are
Okay.
corresponding. I mean,
thought
not
they were
corresponding. These are, oh my gosh, what's consecutive? Thank you. These are consecutive. So that means I have to add them together to equal 180.
Okay.
So my equation would be 6y plus 120 equals 180. So you'd have to subtract 120 from each side and be left with 60. So 6y equals 60, divide both sides by 6, so y equals 10. Okay. All right, number 22, find the value of X. All right, so look at these. So again, we've got to look at the relationship of our angles. We see 2x plus 10. What is the other angle measurement that we know in number 22? 90 degrees. They put that box there. They did not specifically say, hey, this is 90 degrees, but they put that box there so we would know that's what we were dealing with. So in number 22, what is my relationship of my angles?
2x plus 10 equals 90. Alternate.
Okay, so they're not interiors. They're not both inside those parallel lines. Remember, interiors, they both have to be inside here. Okay, so let's look at this. But if these are both parallel lines cut by my transversal, and then this one's 90 degrees, what is this angle going to be? 90 degrees. Okay, so you could say because it's 90 degrees and because we know it's going to be the same, then basically you could say that this equals this, or you could say that 2x plus 10 plus 90 equals 180 because we know these two are going to add together to make 180. Okay, so what do you end up finding that X is equal to? 40 degrees. I'm sorry, not 40 degrees, 40. All right, 24. They've given me 5x minus 24 for one of my angles and 89 degrees for the other. Okay, so when we look at these two, what is the relationship between the placement? What is my relationship here?
Exterior angles.
Okay, so they're both going to be exterior angles, but they're not alternate exteriors, are they? Okay, so let's look at this one first. If this is 89 degrees, what do I know this is? I'm sorry? 91 degrees, okay? So these are my alternate angles, right? And so I could have 5x minus 24 equals 91. And so what would you end up finding that your x is equal to?
Could you work that out? I was kind of confused on that.
I'm sorry?
Could you work that out? I was kind of.
Okay, so when we're looking at these two measures, okay? Okay,
This is 124.
yes.
Okay.
So I can see that this placement and this placement would be corresponding angles, right? Okay, so I know that this, because these would be corresponding angles, I know that this cannot equal this. I could not set these equal to each other to solve. But because these are corresponding angles, then I know that 89 plus something here would give me 180 degrees, right? So 180 minus 89, we said was 91 degrees, right? So now 5x minus 24 is equal to 91 degrees. So 5x minus 24 is equal to 91 degrees. Add 24, add 24. 5x is equal to 115. Is that right? Divide by 5, divide by 5. So x is equal to 21.
Where do we get the 91 from?
I'm sorry, not 21, 23.
Where do we get the 91 from?
Okay, so let's look at that. Whoop. Because we said that we know that these two angles right here would equal 180 degrees, right? So 180 minus 89 is 91 degrees. So if I do not know a corresponding angle, I may have to solve to figure one out using other postulates and theorems that I know. I know that a linear pair equals 180 degrees. I need to know this measurement right here to set it equal to this measurement right here. Okay, so if they have not given me the information I need, I may have to solve for it first before I can solve for my variable. Okay, let's look at 26. In 26, they did go ahead and give us angles that are in corresponding locations. So I can set 7x minus 7 equal to 126. And what do you find that x is equal to?
25.
25. Good. Any questions about that one, or is
I
everybody
got
good?
-7.
Okay, so let's take a look at this one. If I have 7 times x minus 7 equals 126, I've got to distribute first. So 7x minus 49 equals 126. Then I add 49 to each side. So 7x is equal to, what's that? 5, carry my 1, 175. Divide by 7, divide by 7. So x equals 25. Do you see where you made your mistake?
Yes, I forgot to set it equal to 126. I
Okay.
just wrote 7 and then distributed.
Okay. All righty.
Wait, I think we also did 27.
No, we-
Yeah, we did.
it was
Yeah, we said 8 through 26 evens and number 27. So let's take a look at number 27. We have our diagram here. Get my eraser so I can- Okay, so we have our diagram here. And like I said, when I'm dealing with these, I want to look at my diagram and think about everything I know before I even try to read my proof, before I even start thinking about steps. I want to know, I want to look at it and understand it first. So I see I have angles 1, 2, and 3, okay? What do I know about angles 1 and 2? Nope, they're not congruent.
They're consecutive.
They are consecutive, which means I can add them together to equal 180. So I know that angle 1 plus angle 2 equals 180 degrees. What do I know about angle 2 and 3?
They're linear.
Linear pair, which means they add together to equal 180 degrees, okay? So those are the things that I know. Right now, I can't really compare 1 and 3. Whoop, wow, hey, turn around. Well, I guess 1 and 3 are going to be alternate interiors, right? So I know 1 and 3 would be consecutive, not consecutive, congruent. Okay, so we've looked at these. What do these little arrows on these lines mean? They're parallel. Good. I'm glad you remembered that. So I know that those are parallel lines. Therefore, I know that all of my postulates and theorems relating to angles and transversals are going to apply. All right. So in statement 1, what is my given?
P parallel to Q.
P is parallel to Q. All right. Now step 2 or statement 2 says angle 1 is congruent to angle 3. Okay. Why is angle 1 congruent to angle 3?
Because alternate interior.
Alternate interior alternate interior angles. Okay. Now let's look at step 3. Okay. I'm going to look at statement 3 and reason 3. Reason 3 says the definition of congruent angles. I had in the beginning that angle 1 is congruent to angle 3. So what is statement 3 going to be? Angle 1 equals angle 3. Okay, remember?
Angle 3 equals angle 1.
That's fine. Okay.
What's number 2? What's the reason?
Alternate interior angles.
Is
Okay.
this number 3 definition of congruent angles?
Yes, so we just said that statement 3, we go from congruent to equals here.
Okay.
And we went, that's just our definition. Okay. Now look at reason number 4 says definition of a linear pair. Which of these make a linear pair? 2 and 3. So what do you think statement 4 needs to be?
2 plus
Angle 2 and angle 3
Form a linear pair.
form a linear pair. Good. All right. Now, we said that angle 2 and angle 3 form a linear pair. What did we do in step 5?
we set them equals each other.
Well, we had
No.
measure of angle 3 plus the measure of angle 2
We add
equals
them
180.
together to equal
I'm sorry?
We add them together to equal 180.
Well, and so notice that angle 2 and angle 3 form a linear pair. These two mean the same thing, right?
Right.
But here we've used angles and words. What did we use here? We made a mathematical statement, right?
Okay.
So we've substituted these symbols for our words. So this is going to be substitution. Okay.
Is this number 5?
I'm sorry. I jumped over.
Okay.
I'm jumping to 6. Sorry. No. So number 5 is linear pair postulate.
Okay.
Okay. Sorry, I jumped over that. Linear pair postulate. So then from 5 to 6, what did we do for number 6? The reason.
Substitution property.
Okay, so what did we substitute from 5 to 6?
M1 plus M2, or angle 1. plus
The
angle
measure
2
of angle 1
is
plus
equal-
the measure of angle 2
is equal to 180.
equals 180 degrees. We have substituted here angle 3 for angle 1,
Okay.
or angle 1 for angle 3. Okay, because up here we said that they were equal to each other.
Okay.
Down here, I have substituted, instead of saying 3 here, I've put in 1. So that's going to be substitution. And then you can see that statement number 7 says angle 1 and angle 2 are supplementary. And so what is that?
Supplementary angles.
Our definition of supplementary angles. Okay. So like I said, it's the kind of thing where on a test or something, I'm going to give you options to pull from. and you're just gonna have to put them. I'm not as concerned about you knowing step by step how to do a proof as I am you understanding the relationship between the angles and understanding how the different angle relationships apply to the postulates and theorems and the understanding of using them, okay? Because like later on, taking the ACT, it may be that they give you a diagram and they give you one measure and you have to understand that this one measure here, if I were to add it to this one equals 180, so this one and this one are going to be a linear pair, you're going to have to understand all these relationships to be able to solve for an unknown. Okay, so that's my big goal, is not for you to be able to say, start here, end here, write me a proof. Okay, I want you to understand the relationships more so. Okay, so now we have page 148, number 30. We're going to jump over to number 30. And it says, forming rainbows. When sunlight enters a drop of rain, different colors leave the drop at different angles. This is what makes a rainbow. How cool is that? Isn't that fun to understand that rainbows are geometry? Aww. Okay. So see what you're going to be able to tell your family at some point when you see a rainbow. You can say, do you know that that's really geometry? Because these are the, you know, the colors leaving the droplets at different angles, and they're going to be so impressed with you. Okay, so it says for red light, so and when we're looking at this diagram, this is not like all the time. So it says for red light, the measure of angle 2 is equal to 42 degrees. Okay, and so then it says, what is the measure of angle 1? So if we look at our diagram, okay, and if we're looking at, here is the red coming down, notice here is our angle 1. So that would be that these are both parallel lines. It tells us because they've given us these little arrows here to tell us that they're parallel. And then this is a transversal coming through. So if 2 is what they say 42 degrees, then how am I going to figure out what 1 is?
Oh, they're alternate interior.
Alternate interior, which means they are congruent, which means they are the same. Come on. They're alternate interior angles, so they're going to be congruent. They're going to be the same. Alrighty. Then 149, 34 through 44 evens. 149, 34. Okay, so angle measures. Angle 1 and 2 are supplementary. Find the measure of angle 2. Number 34, what is the measure of angle 2? 107 degrees. Number 36, what is the measure of angle 2? 73 degrees. 38. 62 degrees. 180 minus 118 would be 62 degrees. And then how far did I say to go?
40
to 44. All right, so now number 40, write the converse of the statement. I will go to the park if you go with me. So think about if then.
If you go with me, then I will go to the park.
If you go with me, then I'll go to the park is what we're starting with, right? That's our beginning statement. So what is the converse of that?
If I go to the park, then you'll go with me.
If I go to the park, then you'll go with me. Good. Okay, 42. Complete the statement. Given that ray DE is perpendicular to ray DG, and line AB is perpendicular to ray DC. Okay, so let's take a look at this. 42 says if measure of angle 1 is 23 degrees, then what is the measure of angle 2?
You do 6. Wait, hold on. This is not number 72.
No, this is number 42.
42, I mean. Sorry.
Yeah, this is 42. So let's think about what they told us in the given. DE and DG are perpendicular. Okay, so let's take a look at this. That means DE and DG are perpendicular. What does that mean this angle would measure? 90 degrees because they're perpendicular, right? So I know that angles 2 and 3 would equal 90 degrees. And then it also tells me that AB and DC are perpendicular. So AB is perpendicular to DC, okay? So if those are perpendicular and angle 1 is 23 degrees, then what is angle 2?
67.
67 degrees. Because I know this is 90 degrees.
So 67 plus 23 is equal to 90.
Very good. And then number 44. If the measure of angle 2 is 70 degrees, what is the measure of angle 4? Okay, so we said the measure of angle 2 is 70 degrees. What is the measure of angle 4?
70.
Okay, so let's think about this, okay? If I've got 2 and 3 together, what do they equal? 90 degrees, right? So if I've got 2 and 3 together, they equal 90 degrees. So what did it say? 2 was 70 degrees. So what does that mean angle 3 is?
20 degrees.
20 degrees. Now notice that I have got here, I've got another perpendicular, right?
This is a right angle.
Huh? Yes, well, I've got, these are perpendicular, they form a right angle. So if 3 is 20 degrees, what is 4?
7.
70 degrees, good. All right, so that is that on that section. Any questions about anything we've gone over? All right, 3-4. Section 3-4, moving along to page 153. All right, page 153, we have 10 through 18 evens. So it says, is it possible to prove that the lines M and N are parallel? If so, state the postulate or theorem you would use. Number 10, is it possible to prove they are parallel? Yes, how?
3.8, theorem 3.8.
Alternate interior angles.
Alternate interior angles. What I would rather you know is alternate interior angles instead of a theorem number, okay? Because one of the things to mention is in this book, it may be 3.8 because it is addressed in chapter 3. It is the 8th one presented in chapter 3, okay? So 3.8 in this textbook, alternate interior angles, it might be 12.2 in another book. So these, the numbers, the theorem numbers that are naming these are not consistent across geometry, okay? So knowing a theorem number is, I want to make sure you know what it is, not the number. All right, number 12. Can I prove that these are parallel?
Yes.
Why?
Alternate exterior angles converse.
Okay, so they're going to be corresponding, okay? Because since these are, remember your interior, exterior are going to have to do with your parallel lines, okay? So these are parallel. This one is interior. This is exterior. Remember, interior means between the two parallels. Exterior means outside the parallels. So this one's an interior, this one's an exterior. So I can't say interior is the same or interior, exterior is the
Okay,
same.
so they're both not exterior.
They are not, because this one is an interior angle because it's between my parallel lines. So it's inside the house.
I still don't understand how they're corresponding.
Because position, corresponding has to do with position. Okay, so based on the transversal, when it cuts these two, these are in the same position for the parallels. Does that make sense?
Yes.
All righty. Uh-huh.
On 10, 12, 14, I didn't write down.
Okay, that's fine. We'll just add them now. All right, and then number 14, look at 14, yes or no?
Alternate exterior angles.
Okay, so we know that they could be because they are alternate exterior, because when we look at our parallels, okay, looking at the parallels, in between them is interior, outside is exterior. They're alternate because they're on either sides of the transversal. 16, find the value of x that makes R parallel to S. Okay,
X, you have to do 180. So X.
okay, so let's think about this. So we're gonna have 2x plus x equals 180. So 3x equals 180. All right, because 2x plus x equals 180.
I just get 3x
So
divided by 1.
180 divided by 3 gives you 60 degrees. So x is 60. Number 18.
I was
All right.
stuck on this one.
I'm sorry.
I got stuck on this one.
Okay, what is the relationship between these two?
But 2x and 3x.
So hold on just a minute. Alternate interior. They're both inside my parallel lines. They're on either side of the transversal, so they're alternate interior. That means they are equal to each other. So 2x plus 20 is equal to 3x. All right. So if I have 2x plus 20 equals 3x. One of two things. If I subtract 3x from either side, I would have negative x plus 20 equals 0. Subtract 20, subtract 20. So negative x is equal to negative 20. Therefore, positive x equals positive 20. Or if you wanted to subtract 2x from 3x, and then you have x on this side equals 20. Either way, x equals 20. Okay, 154, 20 through 28 evens. Starting with number 20. Is it possible to prove that lines A and B are parallel? If so, explain how. So look at 20. Okay, so do 143 is 143 plus 37 180? Yep, so we've got consecutive interior angles. Look at 24. 24.
Wait, what about 22?
I'm sorry, I jumped over 22. 22. All right, so 22. Look at these. I've got an angle of 106, I've got an angle of 49, and an angle of 54. Now, what do I know that if I were to add these two angles together, okay, notice that if I were to put these two together, and I didn't even have that, what would I know about this angle and this angle? Okay, so I could look at this and actually I would have this one on this side. So if this one is 106, this is 106, which means this is 106 and this would be 106, right?
Well, I'm thinking that line that comes out, you can't see it, but it's supposed to be 1 degree to, unless I had it wrong, but I got that 49 plus 54 would equal 103 degrees in the alternate.
Exactly. So because this number does not equal this number, then I could not prove these are parallels. Okay, because they don't add together to equal the same thing, then I know that these lines are not going to be parallels because they're going to be off a little bit. Okay, so the first thing I have to understand though is I would need to know that I've got to add these together to equal this to find if it's a true statement. Because it is not, then I know that they are not parallel lines.
Could you work out 24 hours?
Do what?
Could you work out 24?
Hang on just a minute, let me get there. Okay. Any other questions about 22?
So they're not parallel? It's not that we can't.
Well, I mean, the question asks which lines, if any, are parallel. And so, no, that's not what the directions say. Is it possible to prove that A and B are parallel? So it is not possible to prove that because if they were parallel, these two angles would have the same angle measurement.
Okay.
Okay? So because they do
So
not
if they
have the
were
same.
equal to each other, we could prove that it's parallel.
Yes. If these two added together to make 106 and this was 106, then they would be parallel because they're equal
But if
measures.
they're not equal, does that mean that they're not parallel?
That means that A and B are not parallel. Okay, because this one's tilted just a bit off to make a smaller angle than this one. So then that means that they are not parallel.
Okay.
All right, let's take a look at 24. Again, we're trying to prove A and B, or trying to see if we can prove A and B are parallel. All right, so what do we know about these different degrees here? Okay, if I'm looking at this angle measure here, what would be my corresponding interior measure with it? Do I have one? What?
I got a huge paragraph for mine, but 60 is a the lower side is a linear pair with that angle that's unlisted, and that unlisted angle is also an alternate.
Okay, so look at this. Basically, if I were to extend out this way, okay, if I were to extend and look at this line going this way, okay, what would I know about this angle here and these two angles here? These would make a linear pair, right? So I would know that 60 plus 60 is 120. So I would know that this angle here, let's see, I don't want to highlight that. Make this a little bit smaller. I would know that this angle here would be 120 degrees. Is everybody with me so far? Okay, so I would know that when I added these two together, they would equal 120. Therefore, what would this measure be?
60.
That would be 60 degrees, right? Because they make a linear pair. So these added together is 120 plus 60 makes 180. Now look at the position of this angle and this angle. What would those be considered? Corresponding, right? What do I know about corresponding angles? They are equal to each other. They're congruent. Therefore, is A parallel to B?
Yes.
Yes. Okay.
Does this use the angle addition postulate?
Yes. Yes. Your angle addition postulate is what we're using for that one, and we're also using consecutive interior angles, or this consecutive interior angle converse. Okay. 20 through 28 evens. That was 24. Let's look at 26. Which lines, if any, are parallel? So let's take a look at this. To know that these are parallel, I know that this angle and this angle would have to correspond, right? Okay, so what is 38 plus 77?
115.
Okay, 38 and 77 is 115 degrees. What do you notice about the other one? It's 114, so are these parallel?
No.
No. And I can see that this one's not parallel to anything because it's going the whole different direction. Okay, so in 26, none are parallel. And then finally in 28, dealing with a proof, angle 1 and 2 are supplementary. L1 is parallel to L2. Let's take a look at our diagram. They have told us that 1 and 2 are parallel. Okay, so in the proof, it told us in the given, I'm sorry, I'm jumping ahead, back up. That's what we're trying to prove, is that they are parallel. What we do know from the given is that angle 1 and 2 are supplementary. So if angle 1 and angle 2 are supplementary, what do I know about angle 3 and angle 2?
They are consecutive English.
They're going to be corresponding, so they're going to be congruent. They're going to be equal to each other. So if 1 and 2 are supplementary, then that means 1 and 3 are also supplementary because they're a linear pair. Okay, so thinking through all those things. So if we look at statement 1, angle 1 and angle 2 are supplementary because, what is our reason? That is the given. I always love the first step. That is my given. Okay. Angle 1 and angle 2 I'm sorry, angle 1 and 3 are a linear pair. That's the definition of a linear pair. Go ahead and take a break. We will come back and try to get through as quickly as we can the rest of our homework answers. Y'all good? Any questions? Okay, y'all take a break. We'll come back and finish up our homework answers and keep on moving. Yes.
I saw my grade yesterday and I was like, wow, that's really, really, really bad.
Okay, so what I want you to be focusing on is number 1, with your homework, looking through as you're doing your homework. If you're getting stuck on things, I want you going back and looking at what we covered in class, okay? One of the things that I'm not liking about doing this format is the whole note writing thing. Some students are real good about just going ahead and knowing what to write down and what to take in notes, but then if I'm not actually writing it on the board, then a lot of people aren't writing notes
Yeah,
either.
that's me. 'Cause
Okay, so what that means is the time that I teach it to you, if that's the only time you see that material, you see it one time, then you try to do homework on it and try to do a test on it, you don't know it from one exposure, okay? So my recommendation to you is that when you're sitting down to do your homework, go back through and look at the examples. Try to identify when you're doing your homework, what problem does this refer back to, okay? And try to make those connections. It may help you that before you sit down and do your homework, that you sit and jot down a few notes from the lesson before you do the homework, because writing that down is going to get it up here better. Okay, so really kind of using what we go over, because one of the things I really started thinking about is if I'm teaching this one time and you're just going on and not looking at it again, then you're not going to absorb the information. Okay, so that makes it more difficult. So kind of maybe figuring out a way to do your own note taking before you sit down and do your homework. Okay, that's going to be one big suggestion. The other thing is going to be, especially before a test, going through and looking at those notes. Are you writing things in your blue folder?
I'm not. I'm
Okay.
trying to I'm just thinking maybe I'm just gonna go through the whole book, take pictures, put it in an album.
Okay. Again, it's the kind of thing, taking pictures is not going to get in your brain as well as writing it. That's why I gave you the folder. That's why I wrote the 2 chapters to show you, because when you write it and you've got that brain hand connection, you've got it in your mind, a picture of what you actually wrote, it goes in there better. If I look at this and move on and try to take a test on it, I don't know what that just did. Okay, I've looked at it, I've studied it, that's great. But then I look, when I get ready to apply it to something, I don't have a clue what it says. But if I sat and took notes on it and I wrote things down, and then I get to something on the test, I've got a visual image that I think of a certain word and I go, ooh, wait a minute, I remember seeing that on that page, and then I'm able to recall that page better. I can see it, I can find things, okay?
Is there also things that we can do for extra credit?
I am going to be getting together an extra credit assignment that I'll be giving you guys tomorrow. So that extra credit assignment will come to you tomorrow. And then since grades, I want to try to have grades posted, by Thursday of next week. So ideally, the extra credit will need to be turned in on Wednesday. And then that way I'll be able to score it and adjust grades accordingly. If you do, extra credit will be optional. If you've got the grade that you want, you don't have to worry about it. If you want to do some, you can. Okay.
Thank you so much.
You're welcome. Welcome, welcome. Yes.
Do you want me to put in my corrections, like homework? Do you want me to hand to you right now?
Yeah, if you want to give me test corrections, huh?
Did you get my test corrections?
And that's another thing, is I haven't, test corrections, I have not graded to,
Okay.
so that may, sending your corrections, having those, will be able to
The
go.
reason I have a low one is because I haven't turned all this in. That's what I thought. Because
Yeah.
I was like, yeah, I'm pretty solid.
Okay.
Oh, no.
So what I was telling them is that one of the things that I strongly encourage you guys to do is as you're going through your lessons, when you're sitting down to do homework, number one, go back through the lesson, do a skim through, go back and refresh your memory before you sit down and try to do that homework. Because if the only exposure you have to these examples or when we're working through a section, if the only exposure you have to it is when I have taught it to you and you've just sat there and listened to me and nodded your head and you haven't taken any notes and you haven't written anything, you see it that one time and then you try to do homework on it and then you try to test on it a week later, it's not in there. You don't learn it, okay? So I highly recommend when you sit down to do your homework, flip through the section first. Look at it, maybe jot down a couple of notes, a couple of highlights, a couple of things that you know, especially when you get to the answer, like if you get to the directions that says which lines are parallel, flip back to in the section when it tells you how to determine if lines are parallel. Jot those notes down. Then when you go to do the work, you go, oh yeah, that's what it is. Again, that whole writing notes connection, that's why I gave you the blue folder to write key things down, because the more you write what you are reading, the more it goes into your brain. The more you remember it, the more you can recall, okay? I know this format is very different. I know it's much more difficult than me standing at the front and writing down notes and you writing down notes too. It takes a little bit more of a level of responsibility and independence to be able to do that. But again, being able, because if you're planning on going to college, professors are going to stand up front and lecture. They're not going to tell you anything. You've got to know what to write down. So in a sense, it's good to go ahead and be figuring that out now. But like I said, this is not the ideal situation with the way that our, you know, in 1 week, out the other. It's just not an ideal situation. I'm not saying I expect you to be at the level of a college student right now and taking your own notes. That's why I gave you the blue folder, and that's why I try to tell you this needs to go in your blue folder. Now, am I going to sit at your house and hold your hand and make you write it in your blue folder? No, I am not. Okay? Should your mama do that? No, she should not. You should take responsibility for that. If you want to earn a grade, you've got to do what you've got to do to earn that grade. Okay? That means putting forth time and effort. That means going through the sections. That means not waiting to cram at the last minute. That means doing what you need to do to learn the information. Okay? And I won't fuss anymore. All right, so we were going through number 28. We said that statement 1, reason 1 given. Statement 2, they already told us that this is the definition of a linear pair. So knowing that 1 and 3 are a linear pair, look at statement 3. Our reason was the linear pair postulate. So what does the linear pair postulate tell us?
1 and 3
Oop. Angle 1 and angle 3 are supplementary, which means they equal 180, right? Okay. Now we're going from linear pair postulate to congruent supplements. Okay, so what are we, if we go to congruent supplements, which two are congruent supplements?
1 and 2.
2 and 3.
Angles 2 and 3. So angle 2 is congruent to angle 3, okay? Therefore, if angle 2 is congruent to angle 3, we see that line 1 is parallel to line 2 because corresponding angles converse. Corresponding angles converse. It is totally fine to kind of get into a system of like, if you do angles, just do the angle sign with an S,
Our
okay?
definition of parallel
Are angles
lines.
1 and 3 supplementary?
Okay, hang on a second. Easton, what?
On number 5, I wrote definition of parallel lines. That was what angle 1 parallel to angle 2.
But because we're having to prove that, we're having to use step 4 to get to prove step 5. So we're having to incorporate these two things. Okay?
So what's number 5? Corresponding.
So
numbers?
number 5 would be corresponding angles converse. Okay, the corresponding angles converse. What was your question? I'm sorry.
I was asking if angle 1 and angle 3 are supplementary, but I don't think they all think they're a linear pair.
Right, and so what does a linear pair mean?
A linear pair means
What do they equal?
180.
So what does supplementary mean?
They equal 180. Okay, I was confused with that.
Yeah. Same, they mean the same thing. All righty, so that was 20 through 28 on page 154. Properties of parallel lines, moving along to page 160. We had 8, 10, and 12 on 160. All right, so page 160 says state the postulate or theorem that allows you to conclude that J is parallel to K. So number 8, it says that J is parallel to N, K is parallel to N. So how can we tell that J is parallel to K?
Theorem 311, if two lines are parallel to the same line, then they are parallel to each other.
Very good. If they're parallel to the same line, they're parallel to the other. Yes.
So those two theorems don't have names, what do we put?
311.
Yeah, that's what I thought.
No, but like.
Um,
we can't use that.
You're right.
And what do we call this theorem?
The 3 parallel lines. Girl.
I guess really in that sense, it's more of just kind of knowing that definition. In the teacher's guide, it does name it 311. So for the textbook answer thing, that would be, you could use that as the answer. That's fine. The main thing is just understanding that parallel lines or lines that are parallel to each other that are parallel to another line, then they're,
Do we need to memorize this for the test, these definitions?
you don't need to memorize definitions. You just need to understand that why they are what they are. Okay. So being able to look at this diagram and see that J is parallel to N and K is parallel to N. This is kind of like that whole transversal thing.
Okay.
If J was parallel to N and K is parallel to N, then J is parallel to K. It's kind of that same transversal situation here. Number 10, given that angle 1 is congruent to angle 2. Okay, so what are those?
Alternate interior angles.
Good, alternate interior angles converse.
Hey, would that be theorem 3.4?
I'll make 3.12.
So alternate interiors converse is going to be (3.8). Alternate interior angles converse is 3.8 on page 150.
I literally stared at that 3.12.
Alternate
That's
interior
not it.
angles?
Huh? Alternate interior angles converse. Okay, so we had 8, 10, and 12. So that's 8 and that is 10. Let's look at 12. 12 says, explain how you would show that K is parallel to J. State any theorems or postulates that you would use. So, alternate exterior angles converse. Good.
Commissioner, some of the problems I am right, I just like write the first letter of all ultimate as for A, E degrees. Like I was like Scott because couldn't fit and everything.
Okay, and it may be like alternate. You could do ALT, exterior, EXT, angles. You could do your angle symbol and converse, CONV. Okay, so that's, figuring out that shorthand method is just fine. All right, so that was 8, 10, and 12. Then we moved on and did 16 through 24 even. So starting on 16, page 161, explain how you would show that K is parallel to J. All right, so what do we know about
35 plus 55 is equal to 90. So this angle down here would be 90 degrees.
Okay, so we already looked at this. I can see or I've looked at it at some point. We know that this one's 90 degrees. So we know that this one is going to be 90 degrees also. And so we've got corresponding angles there.
I wrote both right angles. Is that okay too?
Because N is perpendicular to J, correct?
Yes, because, so you've got your perpendicular line that forms 90-degree angles.
Because we use theorem 3.12.
You could, yeah, so we know that 35 plus 55 equals 90. So N is perpendicular to J, and so K is parallel to J. because of that theorem 312.
So is my answer correct, like wrong or? is it-
Well, you would just have to say, because, yes, they're both equal to 90 degrees, so you need to say that there are corresponding angles to show that, you know, that they are congruent. Okay, then number 18. Explain how you would show that G is parallel to H. Okay, so we've got G and H. If we know that this is 90 degrees, what is this one?
X is equal to 90.
Okay, so we know we've got 90 degrees and 90 degrees, and so if these make 90 degrees, and these are, we've got the transversal there, then we know that those are gonna be 90 degrees as well, okay? So again, theorem
So G is
312.
perpendicular to the transversal.
I'm sorry?
Is G perpendicular to the transversal?
Yes,
Okay.
yes. And then number 20. Number 20, we can see that our interior angle is 90 minus X. Okay, so what do we know about this angle and this angle? Corresponding, so they should be what? They're going to be congruent, which means they're equal to each other. So if I have 90 minus X equals X, okay? And then what do I know about this angle here? Okay, then that's going to be supplementary to X. So when we look at those two, if I've got 90 minus X equals X, add X, 90 equals 2X, so X equals 45. And then here, if I have 90 plus X equals 180, 90 plus 2X equals 180, minus 90, 2X equals 90, divide by 2, X equals 45 there as well, okay? So we've been able to look at those. And in number 20, because they both, because of consecutive interior angles converse, then we know that they are parallel.
How did you get 90 plus X?
Because remember, if this plus this equals 180, so then I have 90 plus X equals 180. Because this angle is 90 plus X, this angle is X, I have to add them together to make 180. All right, 22, 16 through 24 evens. So let's see. Number 22, determine which lines, if any, must be parallel. Explain your reasoning. So let's go ahead and look at number 22. Okay, notice we've talked about our little arcs there, and that we know a single arc corresponds with a single arc, and a double arc corresponds with a double arc. So what do we have here that tells that they are parallel?
Those two double arms.
Okay, and what are they called?
Corresponding.
Corresponding angles. Good. Very good.
So would that mean H and J are parallel and
Yep.
K and G are parallel?
Okay, and then we move on to 24. Okay, so let's look at 24 for a minute. Okay, so look at number 24. We've got lines AB and we've got XW. Okay. What do we know here? Okay, so here, if this one is 90 degrees, then I know this one's 90 degrees. If this is 90 degrees, and this is 90 degrees, and if this one's 90 degrees, this one's 90 degrees. So I can see here, I'm trying to figure out why in my book it says no pairs of lines must be parallel. Okay, let's think about this for a minute. I want to draw this. This angle here tells me that A and W are perpendicular, right? So I see that A is perpendicular to W. This one here tells me that B is perpendicular to X.
So why is it a perpendicular x2?
So if I'm trying to try to see why they would say no lines are parallel.
The exact same problem as the one above it, it's just bigger. It's really all it is.
Well, but the thing is, notice that they have shown us, like, we cannot relate these two things to each other, whereas here we could do corresponding angles. I don't have any angle relationship here to say that they, I'm having to make assumptions, but still, I think I'm just gonna have to disagree with that one.
Wouldn't it be alternate angles?
Well, I mean, it should be, but I mean, well, alternate angles would be, like, alternate exterior would be here, I'm sorry, exterior would be here and here, because they'd have to be
See, I
outside.
don't understand how all those angles are not parallel to each other.
Well, and that's why I'm saying, I think I'm gonna just have to disagree, because if this is 90 degrees, then that means this one's 90 degrees, and this one's 90 degrees, which means this one is. So if these are 90 degrees, I don't know a way of drawing a line that would not make, because if there wouldn't be a way to draw a line that wouldn't be,
They're the exact same.
unless
Parallel.
this one was tilted this way. But we know this one's not tilted this way because it makes 90 degrees here. So I'm just gonna have to disagree with what the book says on this one. Okay. So that was 16 through 24.
All angles are parallel.
That's what I'm saying. All right, so 36, I'm sorry, section 3.6, we've got page 168. So page 168, we have 12, 14, and 16. So in number 12, it says, what is the slope of the line? So if I go to the right one and down one, what is my slope?
-1.
Okay, -1. Number 14, find the slope of the line that passes through the labeled points on the graph.
0.
So if I connect those points, I can see that I've got a horizontal line, slope is 0. Number 16, all right, if I have -8, -8, and 1, 8, okay, from, and the fun thing is that they did not put these points on exact cross sections of my graph, okay, so that means that from here to here is actually a bigger number than 1, because they've said this is where 1 is, okay? So, so what would you have to do to math? Yes. So you'd have to use your slope formula, and what would you find that your
You have -16 over -9.
Okay, and a negative over negative is a positive, so
you'd
you'd have 16 over 9. Okay, so you would have to plug that into the formula. M equals, okay, so flip back.
M equals y2 minus y1 x
Mhm.
cubed minus x.
So you've got to remember the y's go on top. So you would have to do, if you look back on page 165, the slope formula. If you cannot just count it because it's not directly placed on a you know, an intersection of the grid, then you have to use your formula. All right, so we had 12, 14, and 16, and then we have 18 through 32 evens on page 169. I'm going to go through these pretty quickly and just give out answers. If you have questions, let me know and we'll go through them. Number 18, the directions say find the slope of each line and are the lines parallel? My first line, the slope is 4. The second one, the slope is 4, so they are parallel. Number 18, that was 18. Number 20, one line is 1/2, the other line is 1/2, so they are parallel. 22, one of my lines is negative 3/4 and the other one is negative 7/8, so they are not parallel. 24, we go down, it says find the slopes of AB, CD, and EF. So you had to use your slope formula 3 times. Which lines are parallel, if any? So in number 24, the slope of AB is 1/2, the slope of CD is 1/2, and the slope of EF is negative 3. Therefore, AB and CD are parallel. 26, AB, the slope of AB is 3/4, the slope of CD is -1, and the slope of EF is -1. Therefore, the slope of CD and EF are parallel. The CD and EF are parallel lines. So if you're missing these, circle them, make yourself a note. Use slope formula. On these, like 24 and 26, you're having to use your slope formula 3 times. You would have to do 3 calculations here to calculate the slope, then compare which ones are the same, therefore they're parallel. Numbers 28, 30, and 32, we had to write the equation of the line using the slope and y-intercept we were given. So number 28, it said the slope is 1/3, the y-intercept is -4. Remember, our slope-intercept formula is y equals mx plus b, so all I have to do is plug in the value of m and the value of b. So y equals 1/3 x minus 4. 28, slope is 1/2, y-intercept is 6, y equals 1/2 x plus 6. 32, slope is -2/9, y-intercept is -3/5, so y equals -2/9 x minus 3/5.
Wait, so what was 28 and 30, 32 again? You were talking, that's apparently that one.
Okay, so it gave you the slope and y-intercept. So if you're using y equals mx plus b, remember m is the slope, b, so y equals mx plus b. So go ahead and write y equals mx plus b. And then, so now look at this for number 28. You would have y equals, what is m? 1/3 x. Just write the x plus, or actually, but what is your y-intercept going to be? So 1/3 x minus 4. On this one, y equals x.
Plus 6.
Y equals
-2 over 9
x.
minus.
Exactly what we did in algebra, doing the slope intercept. Okay, we have the slope, we have the y-intercept, therefore we can write an equation. All right, so that was 18 through 32 evens. Now we have 34 through 44 evens.
Oh, we do?
On, 34 through 44 evens. So this is page 170. So remember, when we're doing these and I write them,
Wait, 40 through 44?
34 through 44 evens is what I wrote as we were doing class. Okay.
Okay, I didn't do 42 and 44.
Okay, so 34 says write an equation of the line that has a y-intercept of 3 and is parallel to the line whose equation is given. What do I know about parallel slopes? They're the same. So if I have got in number 34, y equals x minus 8. What is the slope of that line? My slope is 1. So they've told me to write an equation of a line that has a y-intercept of 3. So y equals x plus 3 would be a parallel line because the slopes are the same. They told me what b value to use in my directions. They told me that my slope would be the same as the line that's given. So the slope is 1. My value of b is 3, so y equals x plus 3.
Where's the negative 8 go?
That is a line parallel. They told me to write an equation of a different line. So they're two separate lines parallel to each other. 36, 38, and 40, write the equation of a line that passes through the given point P and has the given slope. Okay, so they've given us a point, they've given us the slope. So if my slope in 36 is -2, I would have y equals -2x minus 6 because I use the b value. Number 38, they've given me the slope of 1/2.
Wait, I thought on 36. I thought you plug in the -4 because that's the y-intercept that you plug it into y.
Okay, so in number 36, remember this is the y-intercept. If 0 is my first number, then b is that this is my y-intercept. Remember, for y-intercepts, every x value is 0. Okay, so -6 is b, -2 is m. So if you have y equals mx plus b, you would have y equals mx plus b, because it's -6, it would be -6.
We did the slope formula last year for algebra.
Mhm.
Right?
That's why they're expecting you to know how to do it now, because you learned it last year. And so in number 38, we have point P, which is 3, 2, and 3, 2, 4, and we have a slope of 1/2. Okay, so to be able to write an equation, I have to find the y-intercept here. The number they have given me, 3/2, 4, is not the y-intercept. That is just a point on the graph. So I have to determine what the y-intercept is, and the y-intercept would be 13/4. So number 38, my equation is y equals 1/2 x plus 13/4. 40, they give me the point P, which is -7, -5. My slope is 3/4. I have to use my formula to find my y-intercept. So I find that the y-intercept is going to be 1/4. Therefore, y equals 3/4 x plus 1/4. And then we had 42 and 44. So it says write an equation of a line that passes through P and is parallel to the line given. And so notice here, we are looking for parallel to -3, 6. And they've told us that y equals -x minus 5. So that means our slope is going to be -1. So in number 42, y equals -x plus 3. 43, we have 0.87. Y is equal to 3. What did I say about that? What kind of line do I have if y equals 3? If I have no x value and y is 3, I've got a horizontal line. So I know that I'm going to have a horizontal line for number 44. So y is equal to 7 because it's got to run through that point.
You gave it that answer.
Yeah. So we talked about that one. Y equals 7 and 44. All righty. So, my goodness. We have used a ton of time going over homework, but I'm not real sure how we can do anything else. So let's move on to 3.7 for just a moment. 3.7, perpendicular lines in the coordinate plane. Notice that this is our last section in chapter 3. What does that mean?
We get a test.
We get a test coming up, right? Okay.
Real quick, is this like our last thing to do with During this lesson, but
So
like
in
last
this
Wednesday.
section, yes, in this section, all of chapter 3 is tied together. So that means that anything we've learned in lessons one, in sections 1, 2, 3, 4, 5, and 6 may apply in lesson 7 of chapter 3. Okay? So what we'll be doing is we'll be covering this today. Tomorrow, we're going to be kind of developing a review to talk through what to do. Your test will be given next Wednesday on chapter 3. Okay, so let's go ahead and take a look. It says goal 1, slope of perpendicular lines. Remember, parallel lines have the same slope. What do we know about the slopes of perpendicular lines? Does anybody remember what they are? They are negative reciprocals. The slopes of perpendicular lines are negative reciprocals. Okay? So when I look at these two, look at example, well, first of all, let's look at postulate 18. Again, postulate, green box, go in the blue folder. Postulate 18, slopes of perpendicular lines in a coordinate plane. Two non-vertical lines are perpendicular if and only if their product of their slopes is -1. So that means when I multiply the two slopes together, it equals -1. Vertical and horizontal lines are perpendicular. So if we look at this, if the slope of the red line is 2, then that means the slope of the blue line is -1/2. Remember, we talked about negative reciprocals. One is positive, one is negative. Reciprocals means that they're flipped. Okay? So if I multiply 2 times -1, I get -2. So basically, if this is 2 over 1, here, let me erase that real quick because that looks like a -1. This is the same as 2 over 1. So 2 times -1 is 2, is -2. And 1 times 2 is 2. What is -2 divided by 2? -1. So remember, if I multiply the two slopes together, it's going to equal -1. So that's always a good way to check it. First of all, do negative reciprocals. Okay? A whole number 2, negative reciprocal, -1/2. So let's look at example 1, deciding whether lines are perpendicular. If the slope of J1 is 3 minus 1 over 0 minus 3, that equals -2/3. The slope of J2 is 3 minus a -3, which means 3 plus 3, and 0 minus a -4, which will be 0 plus 4, so that will be 6 over 4. Now, one of the things I have to make sure to do is to simplify fractions. Every time you write a fraction on any kind of anything, always make sure it's in simplest form. So if at first glance you would say, oh, I've got -2/3 and then I've got 6/4. Nope, they're not the same. Well, if I look and I reduce, and I've got -2/3 and then I have +3/2. I have a negative and a positive. Those are opposites. I have 2/3, 3/2. Those are reciprocals. So I have negative reciprocals. Again, I could check it by multiplying the two together. -2/3 times 3/2. -2 times 3 would be -6. 3 times 2 is +6, and -6 over +6 is -1. So based on knowing that my slopes are negative reciprocals, they are perpendicular. Example 2, deciding whether lines are perpendicular. Decide whether AC and DB are perpendicular. So the first thing I have to do is I have to use 2 points on AC, plug it into my slope formula. M equals y2 minus y1 over x2 minus x1. So I have to use that formula again to find the slope of AC. Find the slope of DB. Again, find 2 points on that line. Use my slope formula. M equals y2 minus y1 over x2 minus x1. Find the slope and compare them. I have 2 and -1/2. Again, 2 is positive, -1/2 is negative. So I know I've got my positive and negative. 2 is the same as 2 over 1. So 1 over 2 is the reciprocal. So for negative reciprocals, one has to be positive, one has to be negative, one has to be written with the numerator and denominator. The next one, they are flipped. So if I do have, and then again, I can always check them by multiplying, making sure they equal -1. All right, The next one, deciding whether lines are perpendicular. In this one, it says, I have line H, which the formula is y equals 3/4 x plus 2. Line J, y equals -4/3 x minus 3. All I've got to do is look at those slopes. I don't have to worry about anything else. What the plus 2 and the minus 3 means is that's just the value, that's the b value, that's the y-intercept of each of those equations. Those are two different lines, but their slopes are perpendicular, their slopes are negative reciprocals, so they're perpendicular. All right, now look at example 4. Example 4 is going to take a little more than just looking at it or using your slope formula. Example 4, I'm going to have to first convert my equation to slope-intercept form. So notice if I have 4x plus 5y equals 2, I have to put it in y equals mx plus b form. I cannot just go, oh, 4x, slope is 4. Nope, it's not. So let's go ahead and take a look at this. I'm having to solve for y. So the first thing I need to do is subtract 4x from each side. So I have 5y is equal to -4x plus 2. Divide by 5. Now remember, dividing by 5 means I have to divide each term on the right-hand side by 5. So not only do I have to do -4x divided by 5, but I have to do 2 divided by 5. Okay? So I'm going to end up with y equals -4/5 x plus 2/5. Now I can look at that and see that my slope is -4/5. My next equation, same thing. 5x plus 4y equals 3. Subtract 5x from each side. 4y equals -5x plus 3. Divide by 4. Divide each term by 4. So y equals -5/4 x plus 3/4. My slope of this one is -5/4. If both of my slopes are negative, I know they're not perpendicular. I can stop there. I don't even have to worry about reciprocals. They're both negative, so one's not positive, one's not negative, so I know that they are not going to equal -1. All right. If we look at example 5, writing the equation of a perpendicular line. Again, perpendicular, negative, reciprocal. So just like in the last section when we wrote the slope, we wrote an equation of parallel lines, I looked and I just said, hey, I've got to have my slope is the same. Now I've got to have the negative reciprocal. Okay? So it says line L has the equation y equals -2x plus 1. Find an equation of the line 2 that passes through 4, 0 and is perpendicular to line 1. First, you must find the slope, M2. So that's what they did first, is they found the slope of N2, which was 1/2. Then they used that slope, and they used 4, 0 to find B. So what they did is they plugged in, if they said that 4, 0 was my point, remember 4 is x, 0 is y. So here they plugged in 0 for y, 4 for x. So they have 0 equals 1/2 times 4 plus b. They were able to solve and find that b is -2. So now I have a slope that I need to use my, I've got the negative reciprocal slope. Remember, it was -2 to begin with. My negative reciprocal would be positive 1/2. And then I found my value of b. So I can write the equation of y equals 1/2 x minus 2, because that is y equals mx plus b. All of these things, we're using the same equation, y equals mx plus b, but we have to do other things to be able to find the slopes that we're looking for. Last example in here. Equation y equals 3/2 x plus 3 represents a mirror. A ray of light hits the mirror at -2, 0. What is the equation of the line P that is perpendicular to the mirror at this point? So again, we know the slope is 3, 2. So the negative reciprocal would be -2/3. We know that we have the point -2, 0. So again, all we're doing, if we know -2 is x, 0 is y, plug in x here, plug in y here, Solve for B. We know that the slope is the negative reciprocal, so we plug it into the equation. Okay. I know that we went through all this pretty quickly, but the main thing here is we're always using y equals mx plus b. We know that our slope has to be negative reciprocals. You may have to plug in a given point to find b when you're writing the equation. So let's go ahead. First of all, let's talk through what our homework assignment will be, and then we will talk about the guided practice. Okay, so looking on page 175. Okay, so look at the beginning section, slopes of perpendicular lines. The slopes of two lines are given. Are they perpendicular? All you're doing is looking at them to determine, are they negative reciprocals? So yes or no. So we're going to start with number 8 and go through. Then it says J and N are perpendicular. The slope of J is given. So what is N? You are going to have to write the negative reciprocal there. For 22 and 24, it says to find the slope of AC, find the slope of BD, and then determine, are they perpendicular? So on page 175, we have 8 through 24 evens. Then we move on to page 176. On 176, the first section, decide whether K1 and K2 are perpendicular. So all you're doing is looking at their slopes. Are they perpendicular, yes or no? So we're going to start with number 26 on this page. The next section, decide lines P1 and P2 are perpendicular. You are going to need to solve for y equals mx plus b. Then the next section, line relationships, find the slope of each line, identify any parallel or perpendicular lines. So we will do numbers 26 through 36 evens. Page 177, writing equations. The line with the given equation is perpendicular to the line J at point R. Write the equation of line J. So we will do 42 and 44. And then go down to line relationships starting 47. We'll do numbers 48 and 50. And then that section, it says decide whether the lines with the given equations are parallel, perpendicular, or neither. So you're going to use the slopes of each of those. If they're the same, they're parallel. If they're negative reciprocals, they're perpendicular. If they are neither parallel nor perpendicular, then they are neither.
50 and 60.
So we've got 42, 48, I'm sorry, 42, 44, 48, and 50 on this last page. Okay, so let's go back through that one more time to make sure everybody has their assignments written. Page 175, numbers 8 through 24 evens. Page 176, 26 through 36 evens. Page 177, 42, 44, 48, and 50. Okay. So tomorrow we will start off with a review of this section. Okay. We will go through a review of chapter 3. So you may want to use some time tonight if you need to catch up your blue folder to kind of help you prepare for that. Don't just overlook those folders. They can be a useful tool for you. They can help you, okay? So we'll be going through a review of chapter 3 tomorrow. We will be getting ready to start chapter 4. I will be giving you some extra credit options tomorrow. So that you guys, I will email those to y'all tomorrow. So you'll have those. They will be due by next Wednesday for them to count for this grading period. I have to have them next Wednesday, okay? I'm going to be, just make sure that if you have any test corrections to get to me, you get me those so we can make sure we've got all of our things turned in to be able to get our grades finalized.
Tweet email.
Yes. Yes,
Just
yes.
make sure, like, if it's faded, just text me. I'll just like send it.
Okay.
Whatever.
So the main thing is just now going forward, if you can make sure to label your work.
Yes, ma'am.
Page so-and-so, number so-and-so, whatever, and then that way it'll just help me. because one of the things, it's not just this class, so I've got 30 plus students, and when I'm getting 8 pages from 30 students, that's 240 pages that I'm having to try to figure out where they go, okay? So that's why it's taken me so long to get the grading done, is because I'm having to sort through a ton of pages, and if I don't know what page it is, I'm having to flip through my book, so it is taking hours and hours and hours to get this grading done. So help me out by labeling it. All right, if you guys have any questions, be sure to let me know. If not, then I will see you guys tomorrow morning in the same format, okay? All right, wait till the bell rings. Tell them to wait, tell them to come back.
Get back in there.
All right, so if y'all are ready to go, you're more than welcome to log out if you have questions. I'm right here.
Thank you, Miss Jennifer.
You're welcome. I hope you have a good afternoon.
You too.
All right, thank you, babe.
Bye.
See you tomorrow. Thank you.
All right, bye, Garrett. I hope you feel better. We'll talk to y'all soon.
Thank you.
All right, bye.
My truck is here, right there, and your mom's there. Yeah, your truck is here. There, let's have.
Okay, we're gonna make copies of those pages for us.
Hey.
I need to log out real quick.
I don't care. I never get in trouble. That's because this definitely was